Alright, here's our video on finding unknown lengths with fractions, right? We've done this with integers. For example, right, let's say we had a rectangle right here, right? And we wanted to know, let's say this was 60. The area was 60. And remember, with area, it always has to be squared, so we can just say feet squared. Right? Let's make that better. People see it. 60 feet squared. That's the area of this rectangle. So we can make some guesses, right? This could be a 5 by 12, because 12 times 5 is 60, right? And remember, width comes first. It's width times length, even though it doesn't matter how you multiply it. The way they say it, though, is this will be a 5 by, remember, by is multiplication, a 5 by 12 rectangle, or a piece of wood, or whatever this is. So we can use unknown lengths with guess and check. We can also use it with algebra, but that's for another grade. But now for 5th grade, we can use guess and check. So let's just do one before we do fractions. Let's say, we'll review, this was in the previous video. We have a rectangle here. And let's say it was 24 units squared. We already know the area. So we need to know the width and the length. And we can guess, we can just make any numbers we want that will work for 24. But let's have a condition now. So I'll write up here a condition. They're saying the condition is that the width has to be something to the length, or the length has to be something to the width. So let's just say that the width, right, the width is 2/3 of the length. 2/3 of the length. That means the width is smaller. It's 2/3 whatever the length is. Now remember, of is multiplication for this condition. So let's first make our factors. Well, let's put our factors of 24 here. Well, we know 1 in 24 is a factor. So if we say 2/3 of 24, is 2/3 of 24 1? No, it's not. So we can do, let's just put all our factors in, right? We have 2 and 12. Remember, as it goes down, as the width goes up, the length should go down. That way you won't miss anything. And we have 3. 3 goes in 8 times, right? And 4 goes in 6 times, and that's it. There are our factors of 24. So let's look to see which one you think would work. If we did 2/3 of 8, will we get 3? Let's check. 2/3 times 8. Remember, 2 of is 8. 2/3 of 8. And this will be 16 over 3, which is not 3. It is not 3. So we know that we can't use 3 and 8. So let's try 4 and 6. Let's see if 4 and 6 works. Well, we want something that's 2/3 of 6. Right? So 6 times 2 is 12. 3 times 1 is 3, and your answer is 4. It works. So we know that 4 and 6 work. So the width is 4, the length is 6, and we know 6 times 4 is 24. So now we're going to do it with fractions. And with fractions, it's a little harder. So we have to use guess and check. All right. Let's look at our fraction bars here. You'll notice that when the denominator is greater than the one before it, it's actually smaller, right? Because 1 is greater than half, and 1/3 is greater than fourths, and fourths are greater than fifths, and fifths will be greater than sixths, and so on. This will help you when we're dealing with unknown lengths. Also, you can see that we have 2/4 is equal to half, right? Keep that in mind. All right, so let's look at something. Let's say we had, I'll bring it up here more. Let's say we had a rectangle. Bring it up more. There we go. Wanted to hide today. Let's say the rectangle had an area of 2/3. An area always has to have a measurement squared, right? So let's just use feet. So we want to know the width and the length to give us 2/3 feet. Now let's say they gave you a condition to find this. Let's say that they said that the length, L, is 2 2/3, 2 2/3 the W. What's W? The width, right? 2 2/3 the width. It's greater. So the first thing we want to do is, if we have a mixed number, let's make it improper. 3 times 2 is 6 plus 2 is 8. So we're going to use 8/3. We're going to use that throughout to do our guess and check. We're going to do guess, and guess what? And check. Just like I said. Let's bring it down so you see it. We're going to do guess and check. Now in other grades, there's actually algebra we can do. We'll actually do it in 6th grade. But for now, we're just going to do guess and check. Look at this. What if we had, we're going to have our width, and then we're going to have our length times our width, and we'll get our area. So we're always going to use 8/3 because that's what we started with. Because we said the length is 2 2/3 greater than the width. So if we times this by the width, we'll get our length times the width, and we'll get our area. Where should we start? Well, since we know the area is 2/3, why don't we start at 1/3? That'll give us our length. We'll put a line down here. So that'll be 8/9. 8 9s. 8 times 1 is 8. 3 times 3 is 9. Times it with the width of 1/3. And we'll get 8/27. But we want to get 2/3. So let's use the cross product rule. Right? Or the bow tie method. Looks like a bow tie, right? So 27 times 2 is 54. 3 times 8 is 24. They do not equal each other. So when we did this width, it was too low. It was too low. We need a width greater than 1/3. So remember, if we looked at the chart, 1/4 is lower than 1/3. We need something greater. Let's try half. Right? So if we did 8/3 times 1/2, we're going to get 8/6, which we can reduce, right? 8/6 is 4/3. So we can just say 4/3. So the length is 4/3, times it with the width of 1/2, and we're going to get 4/6. Is 4/6 2/3? Well, 4 times 3 is 12. 6 times 2 is 12. They're equal. Yes. We found our length. We found our width. The width will be 1/2. Let's bring that up so you see it. The width is 1/2. And the length is 4/3. We'll bring it up here. Bring that up higher. 4/3. 4/3 times 1/2 has to equal 2/3, which we showed it did. And we'll do it again just to make sure. 4/3 times 1/2 is 4/6, and 4/6 is 2/3. So this is a 1/2 by 4/3 piece of wood or a rectangle, whatever it is. So that's how we use guess and check. So rewind if you didn't understand. You take with the value they give you, the condition. This is the condition, 2 2/3, which we made improper. And we're always going to use it in our chart here. We did 8/3 times whatever we thought the width would be. Again, we just guessed first. We said 1/3. We started with the third family. And we said it was too low. The width was too low. So we went greater than 1/3. And in our chart, we used 1/2. By the way, if you do something and you find something is too high, well, then you can go lower. You can try the 4th family or the 5th. Okay, so let's look at another guess and check problem. Let's just keep this here so we can see. So again, here we have 6ths. And you can see the 6ths are smaller than 5ths. So what if we had this question? Take this out of the way. We make a rectangle. Right? And let's just say that the area is 1/6 feet squared. We'll use feet, right? So we need to know the width and the length. And let's have our condition, remember? Our condition of what we're trying to find. So let's just say that the width let's say the length, not the width, let's say the length is 2.5. Well, let's make it 1.5. Let's say it's 1.5 the length. So the length is 1.5 the width. Let's get our thing straight today. All right. Now, when you see a mixed number that becomes improper here, that we know the length is greater, right? The length is 1.5 the width. So again, we're going to make this 3/2. Remember, 2 times 1 is 2, plus 1 is 3. 3/2 is what we're going to use throughout this. So let's use guess and check. Let's see. So we said that the area is 1/6, right? Here's 1/6. So let's use something smaller than or greater than 1/6, right? Let's use 1/5. Why don't we start with 1/5, right? So what if we said, again, we're going to use 3/2. And let's say that the width was 1/5. Right? So that'll give us a length of 3/10. That's the length now. That's the width. So what do? We take the length of 3/10 and times it by the width. And we get 3/50. Is 3/50 1/6? Well, 50 times 1 is 50, right? And 6 times 3 is 18, so 1/6 is much greater. So we know 1/5 is too small, so let's look at 1/4 now. 1/4 is greater. Let's see what happens if we use 1/4. So we still use 3/2. Now we're going to say the width is 1/4. Bring that up here. And that's going to give us 3/8. Right? Let's bring a line down here. And we know that the length is 3/8 and the width was 1/4. That will give us 3/32. Is 3/2 equal to 1/6? Well, 6 times 3 is 18. 32 times 1 is 32. No. 1/4 is still too small. It's too low. Let's go higher. Let's try 1/3 now. So now we're going to use 3/2 again. This time we'll use 1/3. And we're going to get 3/6. And what is 3/6? Just 1/2. You can reduce it to 1/2. So if we did 1/2 times the length, we'll get 1/6. And 1/6 is 1/6. So we have it. We have our length of 1/2 and our width of 1/3. All right. Let's look at that for a minute so you see it. We guessed and we checked. So again, width comes first. The width will be 1/3. And the length will be 1/2. So this is a 1/3 by 1/2. Bring that up so you see it. A 1/3 by 1/2 rectangle. Now again, we're doing guess and check here. We're not doing algebra, but it's like algebra. So with algebra, we can find this out by formulas, which you'll learn in higher grades. You'll learn some algebra pretty soon, though. All right, great job today.